Hmm. Yeah, of course. Um, I think the test happens between these two lines, yeah. No, it's not. It happens when I return. It happens here or there. No. Well, no. No. It happens in this one. True. Probably, yeah. I guess the local extreme will be pointing to 5. Which then means that this must be the previous one is the left part of a minimum. So left min. Previous is left min, and that is the case. So is a minimum, and then the previous thing is a left, has a left min bit set. Maybe yeah. Yeah. kind of pointless, I guess. Let's just pass it this pointer, and then maybe you can print the other one, other members. If there is anything, otherwise. Keep it used. Let's pause at this pointer. I'm over tech. My algorithm doesn't even look anymore like grading descents, I have to admit. Do I need an accessor to cubic? No, I don't. Should not. No, I have no tips. Cubic used. fuck? Yeah, well, it's just pause point. This is C++. The hell? Right. Still only have an unknown algorithm. Oh no, we have here another unknown algorithm. Very unknown. Oh, fuck. Interesting. Or suppose I'll have to go to this is printed later than where I'm working. I'm working somewhere here. It's annoying. So I do want to know where the local extreme is pointing to. Maybe I should temporarily make it a member of algorithm. So this thing here. No, it's nonsense. I'm calling this here set local extreme, and that's what I'm printing. That's the minimum here. So my local extreme is definitely pointing at 5. And then I should pointing at 5. So hello, Alexia. Yeah, it's not really right. These two look very much the same anyway. I'm not even going to learn anything, I think, if I print the scale. So probably use the scale of the last one, which is the one that gave me the minimum, I suppose. Let's print the scale. Scale somewhere. Approximation sample node. Yeah, okay, let's just print a sample node scale. So I'm printing the label. Print it here. Scale does not have print on. Let's just print the value. No. I'm going to add a print on. I want to see the full thing. Value. Yeah, that's a lot. This whole thing is a scale. That thing does not have a scale. That thing does not have a scale. Ouch. Yeah, the whole scale is not initialized. Yeah, I guess it cubic used points to the last one that is has a scale. The cubic that you see here is contained in the node that is printed here. So the fact that this line says that it has a minimum means that this cubic was processed for its scale, and that should be cubic used then. And apparently I didn't do that for the next one. And I probably didn't do that because one of the 2 points that this cubic fit through is fake. This value comes from that. Okay. I guess I have to and probably can just use the scale of the last cubic used, which would be almost 2. Already using it here. I must have done this before. This feels familiar. Can't remember where though. It's actually part of whatever's calculating the skill, isn't it? Let's have a look where we do that. Oh, it has to do with matches. Matches. No, this is what I meant. Yeah, let's see if this makes sense. We started local extreme. If we can go to the left, then step 1 to the left. And if that value is, well, I don't need an absolute value because W just gets smaller and smaller. So this is just extreme W minus that. Right. No. Okay, now I need to count how many usable samples we have. That's something like number of usable samples. And usable sample. on type. That's it. Hello. I'm coding very seriously, algorithm to find the global minimum of a function. I want to skip nodes that are closer than 1/1000th of the scale, and I do want to include kind of the local extreme one. I don't think that one is fake, is it? It can totally be fake. Okay, so maybe not special case that one then. Just skip all fix on. And skip. The pro, well, it's probably not a problem. So if it's not fake, it will be one of these, and I'm kind of worried that if I go left from left to right instead of starting at local extreme, that then I found one and then use that one, and then the next one is this one, and that is then super close to the previous one. Therefore, I would skip this one, but I just want to use this one then and skip the previous one. So. I'm just going to have to make 2 loops. I already have 2 loops right here. They already start from local extreme. So we have local extreme, then I go away from local extreme, and then we judge it. So, and then we add it, maybe. I suppose it doesn't matter in which order I add them. The previous code had an array of size 6, and I have absolutely no clue where that 6 comes from. Maybe it is because, no, I don't know. Let's have a look at all the codes. Oh, 5 even. I would say that this is a bug, or well, a potential, you know. Why would this not write more than 5 samples? Probably very, 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 very unlikely, but not impossible. Definitely not impossible, actually. If you just craft the right function, that it should happen. Or not. It's difficult to do. The point is that the scale, we are bored if the scale is surpassed, is the number of samples that still fit a cubic with a certain precision. We use cubics to jump to the extreme of a local extreme of a fitted cubic and find the next point. And so in order to get more than 5 usable samples, I would be both needing to jump over and over, because every time I jump it turned out to be not a cubic, and need a new cubic to get a new extreme and so on, and then still have all the samples fit the previous cubic within 10%. So they're definitely, yeah, certainly, I can't think of an easy way to get more than 5 samples like this. Nevertheless, I don't want to assume that. Okay, so I'm not going to do this, I think. I'm going to do that in these, inside of these loops. But I do want to use the idea of using a lambda. So let's copy this. I have no idea. I really tried to press Shift V. And this thing adds to usable samples, which then has to exist, of course. And it adds pointers to samples instead of iterators. Yeah, well, why not, I guess. Still going to use an array, don't ask why. Static, so it isn't put on the stack or something. Although, if I make it a const expression, that seems very unlucky. Might as well just fill in 6 here, of course, and then use usable sample size. Maybe that is a better. So now if this lambda is called with some new sample, then we calculate the distance to of that sample to the critical point W value, which I already have as well, I thought. No, I call it extreme W. Where is it? Yeah. Which will be captured by reference, no, by value, sorry, that's the default. Which is fine for a double. So we only added if it is larger than 1/1000th of the scale value. Also copied, also captured by a value. Yeah, these are captured by reference because I'm changing them. Oh, to be this one and this one. Or less than that, but that's not necessary because I'm going to run over. We're already onboarding here anyway. So I do my stuff below this line here, and then that won't happen. Might as well remove this then. And then I'm adding a new sample to usable samples. Okay. But yeah, that's kind of annoying because I want to know if it is a fake sample. So really, I would just have to pass up an iterator to the sample node. Sample node derived from sample, so I don't have to change this. And without debugging and stuff, that's just the size of a pointer, which is equal to the size of a double, and so on. I mean, I can just store that here. Everything is an iterator. No, the shirt is not good enough. I mean, I'm wondering, like, will I ever go over 6? But suppose during my testing I never go over 6, and then you make it production code without assertion, and then it's still not good enough. So we really have to abort. Oops. How can I could throw an exception, I guess. Nah. Yeah, I can make it return a boolean, I suppose. I just never want that to happen, really. I mean, not on my watch. No, I can do this. Well, this only skips if it is too close to the extreme. Theoretically, and extremely unlikely, but theoretically there could be two samples that are not close to the extreme, but very close to each other. That is so unlikely that I'm not even sure I want to code this. But yeah, if it happens, I would have a problem, of course, with plotting or fitting a fourth degree polynomial through it. 2 points that are very, very close are not very useful for fitting data. I'm just going into one direction, right? Either this way or the other way. Which means that the distance, which is an absolute value, only gets larger on subsequent calls. Which means I might as well only compare it to the last sample that was added. Yeah, so let's add the local extreme itself. Oh, that won't work. Aha. Yeah. Sometimes that one is fake, so that wouldn't work, but definitely this is not true. This is going to be 0, of course. Hello, Sviatoslav. Oh, thanks. Well, so again, I'm trying to add all samples left and right of local extreme, which is an iterator to a linked list, that are not further away than 1.1 times the scale value, and in terms of the W value, but also not closer to each other than 1/1000th of that. And I don't even know if I can add a local extreme itself, because it might be a fake point, which I also want to skip. So I start at local extreme, and then I can try to add it, but that would definitely fail based on the fact that this will be 0. Yet I want to add it, so I think I should not call add usable sample. I should just add it if it is not fake. Well, not like this then. So if local extreme is not fake, Then we add it. This is okay because the number of usable samples is 0 and therefore it is never larger than 6. It's just the first example that fits in this array. When the number of usable samples is set to 1 here. So then if I try to add the next sample, like for example, here this loops over all the samples on the left until, well, this size only increases, therefore we just abort as soon as this is larger. The rest will be larger as well. So if this is not true, then we have here a left edge that is usable. That is not larger than 1.1 times the scale value. And then I can do add usable sample. Left edge, just past the iterator. And then what I want is that this is going to add it unless, well, unless it's fake of course, but also unless it is closer than 1,000th of the scale value to the previous added value, which in this case would be the local extreme, or not, if it wasn't added. So if there is a previous one, yeah, and so on. So I should not do this. Should not use this. I should just use the previous one if it exists. So if the distance between, well, with all this new thing here, with the previous one, that would be the distance, if it exists, is too large. Well, no, sorry, it's too small. So it is not true. Now we don't add it. I think that works. Okay, so if an overflow would happen, we return false, and then we can't store anything else. It kind of sucks though. Because I would like to have the... I want to have the samples that are as far away as possible. So in terms of not being able to add enough samples, it is extremely unlikely. I would have to start from the other side. But I can't, because now I'm using this loop, which... So I don't know when this happens. Nah. Plus, even if I would do this loop first to find the left edge and then start from the left edge running towards the extreme again, then it's a bit hard to compare it with the previous sample, if you get what I mean. And then we get this same problem again that I described before, I think. That I do want to add the local extreme always. Yeah, I could add a local extreme anyway, like this. First find out the left edge, then add a second loop that runs from the left edge to the center, and then include here also the comparison with the local extreme value. No. Yeah, that's definitely going to allocate memory by now. Oh well. Mhm. Precise, really? So I want to add at most 3 samples now. Don't ask. So an array of 6 should be enough. And we start with setting max samples to, 3 then. Which means we store in 0, 1 and 2. So if this becomes 3 and we try to store in 3, then this will be true and we return false and we abort that loop. And now it's so deliberate that I don't want to know about the assert anymore. Okay, so now a problem here. The first call here is now using the as previous sample, the last one added here, which is far to the left. So that is never going to be too close. And really I want to compare it with the first sample, the first time. So what to do here? This just increments the iterator. Left edge is an iterator, so this advances the iterator to the next element in the standard in the list. I'm having a standard list of it's a double linked list of sample nodes, and I use of course iterators to point to those elements. So yeah, in English I would say, if I write a comment here, then I would say something like, go to the next node. You know, you raise a good point here. I'm suddenly... what? Oh, sorry. Yeah. That's what it does. But I was you confused me because I was thinking, yeah, of course you have to go to the left in the loop. So minus minus goes to a previous one, and I store them left to right. So the first element is the leftmost one, and then we get the next and the next and next, and the last element in the list is the rightmost one. So if we want to go to the left, we have to decrement the iterator. So then we go to towards the first element. It's going more and more to the left. And then this one is taking one step back to the right. And the reason is that now this fails. So the reason I want to one step back is to cancel that minus minus. So that after this loop, left edge points to the leftmost element for which this distance is still less than 1.1 times scale value. So it's still a valid one. So after both loops, left edge points to the leftmost valid sample, and right edge points to the rightmost valid sample. Where valid means that the distance is less than or equal 1.1 times scale value. So kind of the same thing as here, you know. I did overshoot, although in this case I undo the overshoot inside the loop before I break, and here that was not possible. Because, well, if this is false, then we just drop out, so we still have to decrement. Anyways, good question. I like questions about code, as opposed to random questions about what shall I learn next to get a good career or something. You can always ask me something about what you see. But okay, so now I have the problem that my add usable sample does not add it if what we try to add is too close to the previous sample. But the previous sample is now the one the first time we get here. That would be this call. So that is the leftmost one that is added. And I want to start again with the, possibly with this one. And otherwise with the first one that was added. So really what I want is that this one adds things in reverse. Or I could reverse the whatever was added, I guess. Or use a DQ and then add this one adds to one side and stuff. Yeah. Oh, well, I know a solution, but it's getting so complicated. Okay, I'll stop talking and code it, and then we have it. Doesn't matter how complicated it is. First of all, I have to get rid of my lot though. Yeah, that really sucks. So I just copied the lambda into the code. No more lambda. And then we're going to do something like fill it left to right in this loop. Instead of a max samples, I'm going to work with an I, which we start at max samples per side, why not? Well, I want to know if there was already anything inserted here. It's not use number of usable samples here. And then to know if it was already, so it just means if this, wait a minute. To find some different music. So if this is the case, then we already inserted something. So then I can get the previous sample. Oops, where previous sample now is stored at I'm going to store, okay, this is, we start here, I'm going to decrement I before storing it. So it starts at 3, I start to store at 2. And then, let's say it is 1. I'm going to store it at 0, so the previous one is stored at I itself. So that would be good. And then overflow here means that I is already 0. We want to, I set it at 3, and therefore we store at 2 first. And then early next time I stored it at first at 2, and then at 1, and then at 0, and then if you go around, I is still 0, and then we break before decremented even further. And the first time we get here, this is still this is false. Let's make it do it the other way around. I don't like the unequal, I mean. So if it is equal, then there is no previous sample. Otherwise, I use the absolute value between the difference of the previous sample and the left edge. So now I can just do equal the size of the array. What? I. And then stored at I. And here I can do the same thing. Okay, what am I doing wrong here? I made 2 question marks. So did we store... Wait a minute, that's not correct. I think there's always a previous sample now. Or not. No, it's not true. If this is fake and there's nothing on the left, then we would have stored nothing. How to detect that? I'm afraid I have to use different iterators anyway. I have to remember what I is. So the left eye here. So if the left eye is still equal to max samples per side, then there is no previous sample. But only the first time. So they both have to be equal to that. So if we didn't insert anything from the right side yet, and the left side didn't add anything. Okay, now I'm having a problem with this one. Okay, let's first finish this. So if we did not insert anything yet, and the previous loop also did not insert anything, then there's no previous sample. Otherwise the previous sample is simply the one on the left. Either what we just added here or that was added here. And then if that dist is, this thing is not fake and the distance is large enough, then we add it, unless the thing is full. And then we do just a break to get out of this loop. Is this then correct? I think. Yeah, because the radius is just was about to be stored, but we didn't store it, so we are not taking it into account. And then there is still one thing wrong. Well, I'm still using number of samples here, which is not correct. In the end, I should just delete this, so I can't use it anymore. Although I probably need to use it below. Yeah, I might as well define it here. Oh, this is something like the right eye minus left eye, because if we don't store anything, then we never executed these lines. So they are both still equal to max samples per side, and then the difference is 0. And if we store either this or that, then it's decremented. This one is decremented, that one is incremented. So for each, this goes up. So that this is the number of samples. What to do about this one? I want this to be added, but now I have only 3 samples that we can store for left and right. So do I want to store this thing as part of the left side? Or does it not matter where I add it? Or should I make the 6 a 7? Well, I guess I should make the 6 a 7. Or not changed. Hello, noise. Right, so I made room for the local extreme. And then we have a maximum of max samples per side, left and right. And if that thing is not fake, then we store it at, well, at index 3, and then we have 0, 1, and 2 on the left, and 4, 5, and 6 on the right. I also increment max size, which I had set to 6 here, so we don't want to store in the 7th position if we don't have a local extreme. Just 3 on one side, 3 on the other side. That means that the last one is index 5, and then if index becomes 6, then yeah, we have to abort. So that would be here. If it is equal to 6, then we abort. If there is no local extreme, and otherwise this is 7, so everything is shifted 1 to the right. Now, whether or not the local extreme was stored in the array doesn't really matter for where we begin here. We set this to 3, and then we decrement before storing. So we store at 2, and then at 1, and then at 0, and then we abort. So that would be the 3. Well, it doesn't matter if that one is started, but this one is now different, I think. There should be one larger if we have already a local extreme stored at that place, of course. Otherwise we go to override it with the first right symbol that we find. So both this is incremented by 1 as well as the starting point. So this is incremented, and that one should be incremented as well. And then this test is also not correct anymore. Yeah, man, there are multiple ways to roam here. I could just add a new variable, what I set to 0 or 1, and then add it, I guess. So extreme index now should be 1 larger, and then of course if it didn't change yet, and we didn't store anything yet, so that matches. And max size was already incremented. So you just have to set the extreme index now to the correct value. So normally this value was that, and it must be incremented if this is true. But the first the place where I want to store the thing is also this value. So we have to do a post increment. And then now the name of the variable isn't really correct anymore, because it's incremented after we stored it. So it's 1 past the extreme index, really. I'll just call it exactly like that. Substitute. one passed, I guess. And then finally we arrived at code that I think works. Yeah, then for debug output I'll print the number of usable samples, and why not all the samples that we found. So I'm gonna loop over something, and we have an integer I which starts at left eye. Oh, that's annoying. No, wait, not annoying. Or is it? Left eye is the first. Left eye is the first one that is valid. These decremented and then immediately store in it. So if we did not store anything, then it is equal to max samples per site, which is where we stored the local extreme. Or if we didn't, and then that is where we stored the first right one. So that this is definitely the beginning, and then I think less than or equal the right eye. Equals, no, less than right eye. The right eye should be one larger than the last one that was stored. Yeah. Hesitating to use unequal. For integers, people use usually less than. For iterators, you always use unequal. And I'm on the edge. What to do? This case, it's clearly an int. Let's just use less than. I don't know. Okay, usable samples was storing iterators, right? So let's dereference the thing, otherwise I can't even print it. The out is just a macro that writes to an O stream. So this is written to an O stream the way it is written there after the comma. Okay. Int, obviously. Yeah, okay. So down, found the minimum. Okay. And what does it print? Number of usable samples is 3. So this one is still within the scale, and that of course 2 and that 2. It is quite a logical because the scale is 1.96 something. And this goes towards the negative values, so you have to subtract about 2 and then you get minus 47. So yeah, definitely still valid. So we have 3 samples within the scale, none of them being fake. Also nice to see that the fake one wasn't added. I'm afraid that the first thing that I want to test is if we don't have 3 samples. Because we should at least have 2 samples, I think. Yeah. Yeah, of course. We found the local extreme. So yeah, with 1 sample you can never say that it is a local extreme. Unless the derivative is 0, but I don't think then that I count that as an extreme. I just take another sample a little bit to the left or the right. So we have at least 2. And we need 3 now. So what to do if we only find 2 usable samples? I want to test that. I should probably let's see. This test sets on a cubic that it should immediately find those extremes, right? There's a lot of stuff. This the test suite is not failing. I have no idea why not. So we were looking at this one now, probably connected to a dampened sign. Let's remove this one and draw what is happening here. First sample, boing, second sample. It's not a maximum, this is the maximum. And then we should have found the local extreme, I think. Yep, it called it local extreme. You can also see it because it's putting the 2 above it, then it's then that means that it found an extreme. Plus you get a green arrow. No, the green arrow is was already drawn. You see the light green here, lime color. That it's across like that one, but then for the extreme. And yeah, 3 usable samples. So we go to the next one. Now we have what we were looking for, because light green and the one is above it. So we have only 2 samples and we already found the local extreme. Very quickly. Pure by coincidence, of course. Well, it was crafted this way, as per the test suite. We just tried 2 samples and And the second sample is by coincidence between quotes already exactly in that maximum. And then we have number of usable samples, 2. In this case it's not fake, because, well, test suite generated thing, but test suite generates it as a real thing. And we have just 2 points and 1 cubic fitted between them. Probably should not print this shit if the critical point type is none. These are just uninitialized doubles, and I know that they are uninitialized because this is not initialized. What? No, this one. Yeah, then you get this. Right. Okay, so yeah, what to do in this case? You have to get another sample, which means I have to set the W value for wherever I want it, wherever I want to get the third sample, and then return. Go to the old code. Less than 2. Oh, this one is not counting the extreme. So this is equal to less than 3 in our case. So previously I was doing this. We add a step in the direction. I bet there's just a scale size, huh? It looks like scale step. Okay, let's slightly more fancy. It is basically the direction times value, but if the direction is unknown, then we do something more intelligent than not making a step. In other words, I should copy this code. Or maybe I already have it. You never know. Step. Sample node step. There's another one. Don't have a scale step. Well, in that case, I'll just copy it, I think. Wait a minute. Do I even have scale? Yeah, of course. I have scale. See, scale.h. Yeah. Is assert valid? I don't have that. I think I knew. This was basically replaced with this one or this one type. Do I still have horizontal direction to int? Yep, got that one. Okay, we don't have samples anymore, I think. Critical point W. We have critical point W, but yeah. So I don't know. I should be pretty good, considering I've done nothing else in my life, basically. Well, I studied physics, so but I started when I was 30 with C++. After a PhD physics, but yeah. I guess the problem here is that there wasn't even a standard back then with C++. So I only really could learn modern C++ since 2011, when the C++11 standard came out. So most of the things that I use are things that I learned at an old age. I can imagine that someone really smart who is doing nothing else than C++, but was 15 years old in 2011, and then did nothing else, that they might be better. Yeah, you have to start young. When I was young, I did absolutely insane things, but not with C++. No, when I was a teenager, I did things like writing a 3D maze programming in assembly, which had to use a part of the screen RAM, because the computer only had 48 kilobytes of RAM, which costed like a small car. I think one of the things that I still do wrong, because of how I grew up, is that I'm very obsessed with optimization and speed. I mean, I started coding on computers with clock speeds of 2 megahertz, something like that. So yeah, that was very important. I did shake the obsession that I had to have. Well, never was an obsession really, but no, never was an obsession. But I'm talking about the amount of RAM that I used. I just never had enough RAM until I did, and then, well, I think RAM is not really that you say, well, I have to squeeze every bit out of it. It's just you pick a certain algorithm, and that determines how many RAM you use, and well, that's it. And if you have more RAM, then you pick another algorithm, I guess. You never know when people ask this, and then you give a long answer and they don't reply, and then I think, well, maybe they just left already. Maybe they never saw my answer. Why the hell is that not working? I guess he left. It's not being highlighted, the ad. God, I hate people that they ask something and they don't even wait long enough to give me the time to type an answer. In the meantime, I probably should make dinner or something. It's 9:20 p.m. That is a pop-up here in the corner from Google Calendar that tells me that I have to put that garbage outside, basically. Yeah, that too. I keep clicking it away, but what to do with this? I don't have samples. How can I make this decision then? The direction pass undecided, then set the direction to the direction from that is all heuristics, man. Okay, let's just change this to not allowed to call this with dir equals 0. Yeah, or just direction here. In a minute. This thing automatically converts to an int, as you already could see. I just want that int, yep. Sitting a pitch dark again. Can't find my key sometimes. Where shall I add this? I think here. Oops. Include horizontal direction. What am I doing in gradient descent? Wait a minute. Oh. Oh gosh, I'm writing an improvement for gradient descent, aka finding a global minimum in a function. So at least that's what I'm currently working on. I couldn't code for a while, but I figured out that it is because I just slept really, really bad. Changed that, and now I can code again, it seems. So that's good. Yeah, so let's just use that instead of this. I still want to print it though. Print them. Let's print them like that. Now dout is only defined, well, it's defined to be something empty if debugger's code is not compiled in, so that really doesn't make any sense to have there a for loop there if there's no debugging. Okay, so if the number of usable samples is less than 3 in this case, it's already asking for one extra sample, we should have enough. Okay, well, I'm not dealing with state yet. Maybe I'm going to add need extra sample as extra state though, because yeah. So we need to add this state, and then I return true. I'm not sure what. Yeah, it returned true, as in we changed the W value and we want to have a new symbol. Yeah, I don't know. Let's just add it. So this state is set when we need, well, we just don't have enough samples to fit the fourth degree polynomial. Stringify it. That we already have. Yeah, I need a scale object here, right? Where do I get that from? Is that not a used cubic? Cubic used. Cubic use scale value. Okay, so yeah, this is the scale. put there. We don't have that. It's yeah, 3.5 hours earlier here. Number of usable samples is 0. How the hell can that ever happen? Oh yeah, but this is one left. This is one less here. Number of usable samples from the old code is one less. Man. Porting this to my new code is not easy. Let me see how other code looks like when doing that. Nah. We never do that yet, apparently. Turn on the light, sorry, be right back. And I should make dinner, damn it. Why am I not making dinner? Oh. Yeah. Yeah, I should stop. I should make dinner. It's almost bedtime. Huh? I think this is should be extreme. other side than what? Two symbols. Yeah, okay. Hmm. Well, it's not an easy test anymore. Before I did not store the extreme in it. So if I had not enough samples, then this would be 1. Or 0 or 1. If it is 0, we don't have anything. And we couldn't test this. Otherwise, it would have been 1. And then we had only 1 sample that was not the extreme. And that 1 sample then is on one side of the extreme. And then now we have to ask for one that's on the other side. But in our case, we have a local extreme that we added or did not add because it might have been fake. And then we have either a left sample or a right sample, or we have left and right, but a fake. I mean, it's way more complicated. It's, I think I'm just forget assert for now. Yeah, and then I don't have last extreme, but I'm guessing last extreme is more or less equal to local extreme here. I don't have approximation anymore. I have to figure out some direction here. And what is this thing I want? Critical point. I think it just means the extreme itself. The sample, a sample of the extreme. Well, I have that. Yeah. I think CP sample is returning a sample cons reference. So I'm having a local extreme iterator, and if I just dereference that, then that converts to a sample. That should work. No, still have to figure out this. I'm going to eat. So let's write this. Okay, I just write everything. Make. Yep. Okay. I'll be back tomorrow, I think. It's so late that I definitely won't come back here today.